This is Algebra Lesson 6.1, Systems Using Tables. Example A reads, Anne and Bev are walking in the same direction from different starting points at different speeds. Anne starts at the half-meter mark and walks at a speed of 1 meter per second. Bev starts at the 2-meter mark and walks at a speed of 0.5 meters per second. Write equations that represent the walkers' distances d after time t. So we need to recall from previous work our y equals mx plus b, or our y equals a plus bx. They mean the same thing, but depending on how you've learned this in the past, the slope or the rate of change always goes with the x, and the y-intercept or the starting value always goes by itself. So I'm going to write my equation for Anne. Again, we're doing in terms of d and t. So d is like my y equals. Anne's starting point is 0.5, and her rate of change is 1. So 1's going to get the x. That's going to be my slope. So whether I do 1x plus 0.5 or 0.5 plus 1x doesn't really matter. I'm going to go with this model because we have our starting plus how much it changes each second. So Bev's then starts at the 2-meter mark and walks at a speed of 0.5 meters per second. Ooh, I messed that one up, my bad. I want to make this a t, not an x, because we're doing distance in terms of time. So distance here starts at 2 and increases half a meter per second. I almost wrote an x again. With my equations set, I can use those to work on example part B, complete the table. So at 0, we were just given that information. She's at half a meter and she is at 2 meters. My rate of change for Anne is that it increases 1 every second. So all I have to do is plus 1 to get to the next answer. And then plus 1 again. And I'm going to just keep adding 1 because that is her rate of change. For Bev, she started at 2, and her rate of change is 1/2. So every time I increase 1 second, I'm going to add half, or 0.5, to her value. Letter C is how long does it take for the walkers to meet and how far are they from the start when they meet. So we're going to go across this table and look for where our distances, our bottom 2 rows, show me the same value. And that happens right here. They are both at 3.5 meters after 3 seconds. Letter B says, solve the system of equations using a table. We're going to do something very similar, but without the context. My first equation is in that mx plus b form. So 2 is my rate of change because that's by my variable. 10 is my starting value. Starting values always go where the 0 is. So my starting value for my y1 equation is going to be 10. My rate of change is 2. That means as I go to the right, I'm going to add 2, add 2, add 2, and add 2. As I go to the left, I'll do the opposite. I'll subtract 2, and subtract 2. My y2 starting value is 8. This is in the a plus bx form. So 8 is my lone number. That's my start. Not the 4/3, that's the rate of change. Wherever the x is, that's how much it changes by. Now 4/3 is kind of a funky number. If you know fractions to decimals, it's approximately 1.33. So I'm going to add 1.33 to this, and I will get 9.33. I'm going to add another 1.33, but I'm actually going to add 1.34 just because this is a rounded value because it's 1.33 repeating. So we'll make that 10. We'll make that 10.67. And then our next value would be 12. And then we're going to add another 1.33, so that would be 13.33. So it's basically, our decimal is 0.3367, and then 0.3367. So if I work backwards, I'll be at 667. Backwards again, I'll be at 533. And backwards again, I will be at 4. Now, the solution we're looking for is wherever the y quantities are the same. And I see that right here. Both of my y's are 4, so my y answer will be 4. My x that corresponds to that is -3, so my x answer will be -3. That is it for the notes on this lesson. Good luck on the exercises, and please let me know if you have any questions.